So Chris and I want to talk now about what we think will be very interesting is what types of data queries we've executed to bring to you guys to talk through what you see in these numbers. And so there's a series of charts we're putting up here that are a result of doing a query across the entire data lake off of our platform to look at interesting trends. And so here we have an I/O distribution. So again, pretty much everything we do is formed through histograms to think through counts and frequencies. And so here, this is I/Os per second. Here's the percentage of I/Os per second across the entire data set.
Metered at mean. So it's every VM's mean and what their I/O per second count is.
Yes. So you can see that not much happening, right?
Yeah. So that's saying most of your customers are doing very little.
So in our customer base is a pretty dramatic mixture of commercial mid-market to what I would characterize as low enterprise customers. So it's, if you think of the fat tail of the VMware installed base, that's pretty much what our customer base looks like today as a profile.
And we filtered out very small environments that were likely labs and things like that. So this is, yeah.
I suppose there could be DR environments that are sitting there cold with nothing happening and possibly that kind of thing.
But also 50th percentile is not a useful measure.
So click again.
Oh, sorry. Yeah.
Click through it.
Sorry. Yeah, so you'll see.
95th or 99th percentile.
Yeah, those are the interesting ones.
Yeah.
Yeah, because, and from the benchmarking world, we pay way too much attention to average and way too little attention to the level of variation or the 99th percentile.
Right.
And it's somewhere between the 95th and 99th that actually affects the user experience.
Yeah.
Yep.
This is exactly what I learned from Irfan.
Gargling.
Yep. That's the critical percentile. So, I mean, you have to look at this, and you look at the amount of ions that are being emitted, and there's certain, in my mind, there's certain conclusions that I draw, but I don't want to speak my mind right now. I'd like to
pick our brains.
Yeah.
I'm trying to think if there's a metric that I'd rather have than this, because in terms of planning for systems, you need to look at the collection of VMs, the sum in any given minute of the IOPS of that collection of VMs are given, rather than the peaks for each of the VMs, because they may be time skewed.
Right.
So that it gets really complicated to try and use this for any kind of forward planning.
So we filtered out the very small ones, and then we did this distribution over the course of a 7-day period. That's all the filtering we really, and the second isn't really a filter, it's just how we bin. I'm sure it's obvious, but the binning is inconsistent in this diagram as well. You've got less than 3, and then the last bin down there is a 70,000 IOPS range. So if you really were to collapse this into consistent time ranges, say 0 to 10,000, everything from here over would be in the sort of small utilization bin.
Right.
Yeah.
Not that 10,000 IOPS per VM is...
It's non-trivial.
Right. It's non-trivial. So, and the other way to look at this is, and we didn't generate this, but I'll throw it out there, and I then want to encourage you guys to throw questions that you would like to see of our data set, and then we can talk, okay? Should I? Right?
We only have another 15 minutes.
Right. Well, I'm not going to give you the answers right now.
Yeah.
We'll take them down.
But
we can do week-long workshops with you on this.
This is the call Irfan and I have next week.
Yep. So we really want to engage you guys on those questions, because there's a lot there. But from this perspective, you need to start looking at the cluster-wide aggregation of what the IOPS looks like to understand what do I need to support that level of throughput. And
right. and I need when if I'm trying to do smart DRS.
Yep.
Then I want to know things like the I/O generation by VM,
Yep.
99, peaks and over time and over day and week, so that I can get the time division multiplexing advantage of laying the VM that's always busy in the morning
That's right.
on the same host as the one that's always busy late at night.
Yep. With that kind of pattern.
You're collecting that kind of data, but it's the slicing and dicing in Julienne starts getting really interesting.
Yeah, it's
And also even the stuff that you don't know because you don't necessarily know what the VMs are actually doing. So, modeling your VDI workload, for example, compared to your Exchange or SQL kind of workload, due to just numbers, if you've got 5,000 VDI VMs and they, add 20% each, it's very different from 6 SQL servers adding 20% each.
Yeah, I mean, that's the classic storm use cases, right? Where you have to over-provision pretty madly in order to facilitate that peak. Otherwise, a whole desktop installation will not be acceptable.
And we've been working with best practices that are really relatively brainless, like, run VDI on dedicated hardware so it doesn't screw up everything else.
Right. Yeah.
But, if I've got servers that primarily run overnight analytics jobs, well, they're never going to be running at the same time as a boot storm.
Right.
And putting them on the same host might be the most efficient thing to do.
Yep. And moving them around in a timed fashion, because usually the storm cases are scheduled and predictable, right? People come in, they log in. Anyway.
Yeah, I mean, Tintree just released their what they call clustering, which is really smart use of storage vMotion.
Yep.
And it's like, yes, and we took 300 counters instead of 3 counters to decide where we place things.
Yes.
And you've got all that data, and it could generate all sorts of interesting stuff.
So, there's some other interesting pieces here. So, CPU utilization. So, again, because of the resource expertise in the team, we fixate on utilization metrics on all the primary resources.
Okay, the axes are a little confusing because it's percentage versus percentage.
The percentage on the left is the number.
Percentage of my VMs?
We probably
that
should.
fell in this bucket.
Yes, the percentage that fell in this bucket. You could eliminate this because these tell the story. 62% are less than 5%. 60% of the VMs.
Right.
Use less than 5% of the available CPU that's been allocated to them.
Yeah.
At 50th percentile. So it's a third percent. I'm just going to make it that much harder on you.
Yeah.
When metered, but then if you look at it again, because 50th percentile is not that interesting, if you change it to 98th percentile, it levels out a little bit more, and you start to see
Right,
better
so this
distribution.
is now
Closer to peak.
approaching to peak.
Yeah.
Yep.
Yeah, and then I want to see it by host so I can see, because I don't trust automatic DRS, whether I need to do, once a week, whether I need to do manual rebalancing. And, then it becomes, and at what time of day does the peak occur? And, and down the rabbit hole of analysis we go very quickly.
Yep. I mean,
And at some point, we have to come up with simplifications to avoid paralysis by analysis.
yep.
Because, I'm just a data geek and I could live in there for a while before I actually decide to do something.
And as people, so one of the things we talked about earlier that is going to drive all this even crazier is when you introduce decisions around hybrid formation. So when you start to look at, like, VMware's done some amazing partnerships, like with IBM SoftLayer, to facilitate burst mode. And if you follow what's going on with NSX and the ability to magically extrude your network and all the policies into a public cloud provider to deal with this
Yeah,
portion.
but 186,000 miles per second, it's not just a good idea, it's the law.
Oh, yeah, that. There's some really, I think the way that's being done will facilitate doing burst mode, which has kind of been a dream for a while. But when that does arrive, then understanding peak like this is the critical part to figuring out what to provision and what to place locally versus what's going to end up in a public cloud provider. So do this one. Yeah.
So you saw from both of those too a consistent theme of what I describe as underutilization of the resources in general. And so what we did then is took a look at every VM in the global data set and did it for CPU. We tracked the utilization of CPU over a 7-day period, created a histogram, and then ran right-sizing scenarios. The right-sizing scenarios included 3: cost-conscious, where you would knock the CPU down to its 98th percentile utilization and round up to the next logical increment, 1 or 2, 4, 6, 8. Conservative would take you to peak utilization over the 7-day period and then round up. And paranoid would take you to peak and then add 25% and then round up to the nearest CPU. So in other words, if you started at a configuration of 8 vCPUs, at peak you used 20% of that, we would round you up to 2 vCPUs. In this scenario, this scenario, this scenario would be 4 vCPUs because we'd add 25% on top of it. The available savings in the global data set was pretty surprising. 55.3% in the cost-conscious scenarios of the provisioned vCPUs could be repurposed. 22% in the conservative scenario, this is based on peak with a roundup, could be repurposed. And if you went paranoid, if you went to peak and then added 25%, you'd actually have to add 10% more vCPUs into those ones that had now burst beyond with the extra 25%. So just gives you an idea of how you could start to twist these dials in these types of scenarios. Another one we did was we looked at the knowledge base articles. One of the sub-apps within our environment is one that maps your particular configurations to appropriate knowledge base articles and identifies critical and high importance KBAs, as well as a bunch of other different levels. And it surfaces those that are critical. And we found that on average across our customer base, our customers have 34 unaddressed critical knowledge base articles on average. They have, if you add critical and high, on average 246 unaddressed knowledge base article, and the number goes really high if you include all of them, but some of those are just sort of the informational long tail. The point is there's a lot of risk in the environment, and our application also, just based on mapping configurations, can start to give insights into what those might look like. Yes, sir?
Do you have any customers that are running essentially operationally optimized all the time? Like, do you have somebody running at sort of peak perfection?
No. Wow. Here's what I'll say. Our customers tend to grade themselves uniquely, but very specifically. So I can think of some customers in particular, they're grading themselves based on how closely they can get to an 80% utilization of their available memory. That's what they grade themselves on. So a lot of the rest of it doesn't matter. Obviously, they don't want to have degraded performance, but they look at the utilization of memory, and if all of their vCenters are running close to 80%, they give themselves a thumbs up. Others have different metrics. But optimally all the time is probably actually a risky kind of place to be, and I'm not even sure what it looks like, to be completely honest. But they do get very close if they have these specific things that they're focused on grading themselves on.
I mean, I guess this is sort of tongue-in-cheek, but is there a metric for this is the point of diminishing returns?
Huh.
That's a good
A
question.
statistically derived number? I never thought of coming up with that, but I'm sure it is. If I go back to this slide,
To some extent, it's, on kind of completely reasonable measures like, how many knowledge base articles have I not acknowledged?
yes.
Yeah.
To say I'm better than 80% of CloudPhysics customers
Right.
would be, the satisfaction point, if not the point of diminishing returns.
Right.
Yeah.
Right. But a lot of it has to do with the trade-off. Cost is the other element. So I put up this slide earlier, and I talked about resource utilization versus performance, and that is a key thing. The cost is the third element, which is what John was talking about in this meta service quality management idea. And so at some point, I'm pointing out effectively, if you think about this abstractly, I'm pointing out 3 points on a cost curve here that you can decide, and somewhere in here is where you actually are today. And you can decide what's my risk. My risk is such that I want to actually add more CPUs. My risk is such that I'm going to run at the risk of about a half an hour per day of degraded performance due to CPU pinning. You have to figure out where you fall. And we do provide, in a lot of the widgets and things like that, these hoverovers that tell you where you compare to the rest of the CloudPhysics data set, so you can judge how you fit in, right? Somebody like Anthony is a sophisticated user like that. You see him running with greater consolidation ratios and things like that. He knows what he's doing. And then there are others who aren't as sophisticated as he is, and they are running at like 20% of the data set on average and things like that. So,
And we have to assume that any of your customers is more sophisticated than the average of your non-customers.
just because they have CloudPhysics.
Well, just because they realized they needed more data.
Right. Right.
You know.
Right. Probably true. Any other questions? Yeah.
Just because I had mentioned earlier about you talked through the partner edition and the vendor edition.
Yep.
I can see that being a hugely valuable addition for two different ways. If I want to move from a 3-year-old bunch of servers to something new, if there was a way I could plug in, I need HP Deal 380s times
Right.
5 of them, and that kind of thing, where obviously it would be revenue from you from be it a partner or either through the partner channel or a
Right.
vendor, to do a what-if analysis on new hardware. But also what would be really useful is if I'm having performance issues on my NetApp Pure EMC storage array, for example, if I'd be able to share my CloudPhysics performance data with a vendor, so I can log a call for them, and then instead of having to say, oh, can we download the logs, please? And because
Right.
that data is already passed, it's not happening anymore. It was slow yesterday, it's fine now. Can you tell me what happened? They have no idea.
Right. Well, so the second of the two approaches is going to be interesting once the CloudPhysics app, vApp, really becomes pervasive, because it has to be there for me to tell you yesterday.
Yeah.
And so I think that's a really interesting idea. And I will say that both in channel partners and vendor partners, we have relationships where people install our observer through their own purposes for these different use cases we described in the developer edition, and they leave it running because they check back in to see, did we size that appropriately? Is there a need for more? Like they want to look at before, use that information to size the refresh that you described, and then look a couple months later and be able to verify. If it's not, is it because the customer changed something? If it is, then I'm good, and so on and so forth. So that's a use case. That use case is already in play today. I think the other one where you're sort of using us ad hoc for support, we've discussed that internally as well, but we don't.
Well, not necessarily ad hoc, but using and paying for you to use all your data, and then just having some sort of extension or some approval process. I suppose you could do it in an ugly way by running a WebEx and your partner viewing it, but that would be. It could be nice to know if you were a NetApp customer, that they would be able to connect immediately to your CloudPhysics environment and have access to all the metrics, and they can go, it's actually slow because the disk has failed, or an aggregate is rebuilding, or whatever it is.
Yeah.
Just not.
No, it's good. It's a good point.
So you're giving us information about there's a troubleshooting aspect to it, like obviously there's some I/O contention here, etc. Do you also have information on how long it takes to remediate? And is that something you can surface up?
Well, we can see when the remediation has happened because the environment has changed.
Right.
But again, the remediation today is focused on giving people an on-ramp directly into the right context within vCenter for them to take the action that they need to take.
Yeah.
But just, I don't know if it would be how useful, but it would be interesting to get sort of baselines on how long does it take, like what's the average time to fix this problem across all your customers.
That's a good idea.
So one of the things that people do with our platform is baseline an environment, like you're saying, then they just leave it in place, and then by getting a baseline report for what happens in terms of changes that have occurred over time, to some degree the data is already there to do that, but I'm going to record your question, so we'll see where that goes.
And also, any more information you can give on networking would be great, because that's part of the missing piece. vSphere's got great analytics for the storage, but the network latency in the middle.
Okay.
It may not be a storage problem; it may be a networking problem.
NSX network implementation.
Yeah, we'll get back to you on that.